these two line segments, I know that this line segment corresponds to this line segment here. So I would say that line segment AB is congruent to line segment EF. And I am telling you that they're congruent. I'm telling you that they are the same shape, same size. We don't know what that size is, but we know that they're the same. So notice that when I'm using the two segments, I've got a line segment over them to name them, and I have a congruency symbol. There's no numbers attached. I don't know what the length is, but I know that they are the same. Now, let's say that I have these two rectangles down here in red, and let's say this is AB, and we'll just say this is EF, but now I know that this is 6 inches and this is 6 inches. I can now say that AB is equal to EF. Notice that there is no line segment symbol above them, and notice that I've got an equal sign here between them. So the difference is when you see the congruent sign, you have line segment symbols above the letters, and there's no number attached. When you see an equal sign, that means that we know what the actual length is. Okay? So that's the first thing. The second thing is it's the same way with angles. So let's say that this is angle W and angle X. Okay? If angle W, we say angle W is congruent to angle X. I don't know what the angle measure is, but I know that they are the same. So again, there's no numbers attached. That's why I have the congruent symbol. If I do know the angle measure, like say this is 30 degrees and this is 30 degrees and this is angle W and angle X, then I would say the measure of angle W is equal to the measure of angle X. Again, when there's number signs attached to something, then we have an equal sign. And then we have this M in front that tells that we know the measure. We know what the actual number measure is. Okay? All right, so there's some things. So, oops, I don't know what happened here. So the other thing that kind of stumps people is the difference between the transitive property and the substitution property. Okay, and there's two things that kind of separates them a little bit. One thing is that the transitive property you can have of equality and you can have of congruency. Okay, but substitution you can only use when the equal sign is used. So again, the transitive property can be used when an equal sign is used or when a congruent symbol is used, whereas the substitution property can only be used when something is equal to each other. That's the one thing. The other thing is that substitution can only be used when you are replacing, I'm sorry, totally messed myself up. Transitive can only be used when you are replacing an entire side of something. Substitution can be used when you are replacing pieces. And what I mean by that is, if I have x plus y equals z, and I have x plus y equals m, because I have a whole side here and I have a whole side here, that means I can say z is equal to m because I'm replacing a whole side. However, if I say x plus y equals z, but x equals m minus y, I can't replace the entire thing because I don't have an entire side that's the same. But I know that x is equal to m minus y, so I would replace that over here. I would replace this with this x that's right here. So again, transitive is when you can replace an entire side of an equal sign. It doesn't have to be the same side. It could be the left or the right. But substitution is when you're going to replace pieces. But again, substitution is only when there's an equal sign used. Transitive property is when either of them are used. So there are times when you can use either one of them, but just know, because like technically up here, you could also justify this with substitution as well as transitive property. But just be aware that there's times that you could only use transitive and you can only use substitution. Okay? All right, so let's work through. We're going to do 3 proofs, and these are from your textbook. All right, so this first one, it says, so we have this angle, and it says that N is the midpoint of MP. So if n is the midpoint of MP, that means that a midpoint splits a line segment up into two equal parts. So we know that this segment is congruent to this segment, okay? And then it says Q is the midpoint of RP. So again, that means that this segment's congruent to this segment. So I'll address that again in a second. But these are givens. So N is the midpoint of MP, that is a given. And Q is the midpoint of RP, that is also a given. So we want to always start by identifying givens. The next given is that line segment PQ is congruent to line segment NM. Again, notice how that's written. You've got the congruent symbol, you've got the line segment symbols over the letters. That's because there's no numbers attached. We know they're the same, we just don't know what they are. So PQ is congruent to NM. Well, if I look here, notice that's not the very next thing that's written. That's okay. You can write all of your givens at once, like at the very beginning if you want, or you can space them out. Although I am writing this particular theorem this way, or this proof this way, it doesn't mean that this is the only exact way. Sometimes there's other ways around it. And I use the example in class. If you're driving from the mall to your house, you don't have to take the same exact road home every time to get home. There's a couple of little alternate routes that you could go to get home. And so it's the same way with proofs. There may be a couple of little different turns you can take, but ultimately it's going to get you to the same place. And it shouldn't be very, very different. You know, it should be about the same. So going back to the proof, so N is the midpoint of MP. Well, here in this number 3, I'm looking at number 3, it says that PN is congruent to NM. And we know that that's true because that is the definition of a midpoint. Okay? With proofs, you do not want to assume anything. You don't want to say, well, of course, if it's the midpoint, that means that those two segments are congruent. You have to explicitly state that. You can't assume that somebody looking at your proof knows every single thing about geometry. So you have to define every statement that you make, justify every step that you make. All right, so N is the midpoint, so that means these two segments are congruent. Q is the midpoint of PR. We've justified or we've shown that PN is congruent to NM. So now what we want to do is we want to look at this next step. So we've got that PQ is congruent to NM. PQ is congruent to NM. That was given. We know that PN is congruent to PQ. Well, how do we know that PN is congruent to PQ? And that's going to be the transitive property of congruency. Transitive. You can just write property of congruency, or you could put the congruency symbol, something like that. But here's how we know that. You can look at the picture and say, well, we know that if this segment's congruent to this one and these two are congruent to each other, well, then these two have to be congruent to each other. That's one way of looking at it. Or you can look at the letters. You can say, well, if PN equals NM, PQ equals NM, then PN equals PQ. That's the transitive property of congruency. And we have to use the congruency symbol here. We can't say transitive property of equality because we are using the congruent symbol here. So it has to be transitive property because substitution is only with equality. So it has to be transitive property. Number 6 says PQ is congruent to QR. PQ is congruent to QR, and that is going to be definition of a midpoint. So let me kind of go up here a bit in this. Okay, so PQ and QR. If we've already established that Q is the midpoint of RP, that means that PQ is congruent to QR by definition of midpoint. And so then, therefore, by default, PN has to be congruent to QR by transitive property of congruency. And again, that's this whole thing here. If PN is congruent to PQ and PQ is congruent to QR, well then PN is QR. So you can kind of see here, if I've got the PQs, I've got them left with PN is equal to QR. So that's the transitive property of congruency. All right, let's try another one. All right, so this one deals with angles. This one, notice I don't have the steps. I don't have that, we're totally going from just working through it. And so again, we're going to start with what we know. So I'm going to put, that's not, okay, so we'll do my statements over here, and we'll do the reasons or justifications, whatever you want to call them, on the right. Okay? So let's start what we're given with. We are given that BD is an angle bisector of ABC. Now, an angle bisector splits an angle up into two congruent angles. So we know that this angle is congruent to this angle. That's what an angle bisector does. So BD is angle bisector of angle ABC, and that is given. And I'm going to change colors here just to kind of make things stick out a little bit, okay? And then we know that angle ABD is congruent to angle 1. Angle ABD is congruent to angle 1, and that is also given. So what we're trying to prove here is we are trying to prove that angle DBC is also congruent to angle 1. Now, we know if these two angles are congruent, and if this angle is equal to angle 1, well, by default, this angle must be equal to angle 1, but we have to show that, okay? So, first of all, what I want to say is if BD is a bisector, then that means that angle ABD is congruent to angle DBC by definition of angle bisector. Okay, so these two angles are congruent to each other by definition of angle bisector. And so then we've already shown that these two angles are congruent to each other because that was given. So therefore, angle DBC is congruent, that was funny, to angle 1 by transitive property of congruency. So by transitive property, if this is congruent to this, well then by transitive, this must also be congruent to this because we'd already proven that or been told that those two were congruent to each other. So that's transitive property of congruency. All right, and then the last one that I want to do is talking with angles. Remember, supplementary angles are two angles that when added together equal 180 degrees. So again, we're going to do our statements. And we're going to do our justifications over here, or we can call them reasons, whatever you want to call it, okay? All right, so we have that angle 4 and angle 5 are supplementary. So angle 4 and angle 5 are supplementary. I'm just going to write sup, and that's given. And then we know that angle 5 and angle 6 are supplementary. That is also given. So what we're trying to prove is that angle 4 is congruent to angle 6. Okay, so we're trying to prove that angle 4 is congruent to angle 6. So the first thing I'm going to say is that, and I'm going to run out of room, I can already tell, the measure of angle 4 plus the measure of angle 5 is going to equal 180 degrees because that's what the definition of supplementary angles is. What am I writing there? Definition of supplementary angles. Okay. Then I'm going to say that the measure of angle 5 plus the measure of angle 6 is equal to 180 degrees. Again, that's the definition of supplementary angles. Well, when you think about it, I can say that the measure of angle 4 plus the measure of angle 5 equals the measure of angle 5 plus the measure of angle 6. Because didn't we just say that both of these are 180? So 4 plus 5 is 180, 5 plus 6 is 180. So by substitution property, they are both equal. They are all, those two sums are equal to each other. Again, notice I use substitution. I have an equal sign here, and I'm replacing entire sides. I'm replacing entire sides here. So that's substitution property. So then let's see what we have next. So then if I subtract the measure of angle 5 from both sides, that leaves me with the measure of angle 4 equals the measure of angle 6. That is the subtraction property of equality. Okay, and so then we have this last step, which is that angle 4 is congruent to angle 6, and that is definition of, that's not enough, of congruent angles. So let me elaborate on that last step a second, okay? If you are wanting to go, like, if you have that angle 1 is congruent to angle 2, we know that the measure of angle 1 equals the measure of 2. But the reason we know that is because of the definition of congruent angles. The definition of congruent angles is saying that if they are congruent, that means they have the same angle measure. And I know that it sounds silly, but you can't just go back and forth between using congruent signs and equal signs. You have to justify that when you do that step. So this is that justification. So whenever you're going to go back and forth between the equal sign or the congruent symbol, it's going to be definition of congruent angles. You can do the same thing with segments, with line segments. You can say definition of congruent segments. So that's what happened here. We had, through our proof, we proved that the measure of angle 4 was equal to the measure of angle 6, but that's not what this said to prove. This said to prove that they're congruent. So if their measures are the same, well, that means that they're also congruent. So that would be definition of congruent angles.